On a clear night, you can see around 3,000 stars, and with a modest telescope, millions more will pop into view. Most of these stars orbit around a massive black hole called Sagittarius A. This compilation of stars is called a galaxy, and we're part of one called the Milky Way, and it holds around 100 billion stars. Further in space is a spherical mark scientists have called the observable universe. We are in the center of this mark. It shows from how far away light has traveled to Earth, so the furthest we've seen into space is to the edge of the mark. That's 47 billion light years away from Earth. Anyway, according to an ESA study, there are between 1 sextillion to 1 septillion stars in the observable universe. But it should be noted that this is just a very rough estimate, and not all galaxies are the same. For reference, there are about a quintillion grains of sand in the biggest desert on Earth, and 7.5 sextillion of those on Earth as a whole. But this again is just an estimate, and with the same problem, the depth of the sand on beaches can vary. Then, there are approximately 1.6 planets per solar system, meaning with simple calculations, there are about 320 sextillion planets in the universe. That is in our universe alone. Imagine if there are other universes similar to ours. The possibilities quickly become endless. And still, out of all of these planets, we are certain that at least one holds life. Given these staggering numbers, it seems almost certain that life must exist somewhere else in space than just on Earth. This is the lore behind the famous Fermi paradox, a puzzle first posed by the brilliant physicist Enrico Fermi. The Fermi paradox has been questioning scientists for decades about the theoretical existence of alien civilizations. In this deep dive, we're going to break down what the Fermi paradox is all about. We'll look at why some well-known astronomers and physicists think we should have found aliens by now, and why others say it's no surprise we haven't. We'll check out some of the cool tech scientists are using to search for aliens, from giant radio dishes to some interesting space telescopes. We'll also have a look at some of the wild ideas people have come up with to explain why we're not hanging out with little green gnomes and why we are still all alone. Whether you're a space geek or just curious about what might be out there, this exploration of the Fermi paradox will get you thinking. Will we cut through the saying and get to the heart of one of the biggest mysteries in space science? Origins of the paradox. The Fermi paradox is named after the Italian-American physicist Enrico Fermi, who first posed the question in 1950 during a casual lunch with colleagues at Los Alamos National Laboratory. The conversation had turned to the possibility of extraterrestrial life when Fermi famously asked, "Where is everybody?" This simple question encapsulated a profound contradiction. Given the vast number of stars and planets in the universe, and the apparent ease with which life arose on Earth, why haven't we encountered any evidence of extraterrestrial civilizations? Astronomer Michael Hart later formalized the paradox in a 1975 paper, which argued that any technologically advanced civilization should have colonized the entire galaxy within a few million years. This became known as the Hart-Tipler argument, after physicist Frank Tipler expanded on it. The Drake equation. To better understand the likelihood of extraterrestrial civilizations, astronomer Frank Drake developed an equation in 1961 to estimate the number of detectable civilizations in our galaxy. The Drake equation considers factors such as the rate of star formation, the fraction of stars with planets, and the likelihood of life evolving to intelligence. While the exact values for these factors are debatable, even conservative estimates often suggest that there should be numerous civilizations in our galaxy. This apparent contradiction with our observations forms the core of the Fermi paradox. Experimental approaches. Many scientific experiments attempted to address this endeavor, such as NASA's exoplanet research and technosignature searches, where astronomers have looked for signs of advanced civilizations such as Dyson spheres. But one experiment stood above all, called the SETI experiment. The search for extraterrestrial intelligence. SETI, in short, is a collective term for scientific activities aimed at detecting intelligent extraterrestrial life. Project Ozma. SETI began in earnest with Project Ozma in 1960, led by astronomer Frank Drake and some other scientists who later formulated the Drake equation. This project used a 26-meter radio telescope at Green Bank in West Virginia to examine two nearby sun-like stars, called Tau Ceti and Epsilon Eridani. For 400 hours over 4 months, Drake and his team listened for any signals in a narrow band around 1,420 megahertz. This frequency is known as the water hole. It's significant because it's naturally quiet and close to the emission frequency of neutral hydrogen, which alien astronomers might also find interesting. While Project Ozma did not detect any signals, it set the stage for future SETI efforts. Common unclarity and misconceptions. The Fermi paradox tends to be misunderstood or oversimplified, so here are ways of thinking you should try to avoid. 1. It proves aliens don't exist. The paradox doesn't prove or disprove anything. It merely highlights the apparent contradiction between expectations and observations. 2. We just haven't looked hard enough. While our search capabilities are limited, we've been actively looking for over 60 years with increasingly sophisticated technology. 3. Aliens are deliberately hiding from us. This zoo hypothesis is one possible explanation, but it requires all alien civilizations to agree on this approach, which seems highly unlikely. Possible explanations. 1. The Great Filter. Proposed by Robin Hanson, this suggests that there's a developmental stage that's extremely difficult for civilizations to pass, explaining why we don't see any advanced aliens. 2. Rare Earth Hypothesis. Developed by Peter Ward and Donald Brownlee, this argues that the conditions necessary for complex life are exceedingly rare in the universe. 3. Simulation Hypothesis. Philosopher Nick Bostrom suggests we might be living in a computer simulation, one such as the Matrix, explaining why we don't observe other civilizations. 4. Dark Forest Theory. Popularized by science fiction author Cixin Liu, this proposes that civilizations remain silent to avoid detection by potentially hostile aliens.